So let's start our very first session. The first session is seamless Passkey Authentication with Flutter Firebase on their journey on Banking App. So please welcome Shohei and Kyo.
Hi everyone. Konnichiwa. We are from Manipur. I'm Kyo
and I'm Shohei.
In this session, we'd like to share our experience with Passkey implementation and explain what Passkey is and show you how you can create one yourself. Before we dive into that, let's start with a quick self-introduction. Hi, I'm Kyo. Right now, I'm working as a Flutter developer on a bank app for Manipur, Android developer on a credit card app for another company, iOS developer for different clients. Even though I have more experience with native development, I actually enjoy working with Flutter more. That pretty much sums up what I'm working at the moment.
Yes. Okay, thank you. And hi again, I'm Shohei, and I go by the name HeyHey1028 in SNS, and I'm a Flutter tech lead in a company called Manipur. And I've been working with Flutter since 2019. And outside of my work, I'm one of the member, the co-organizer of one of the biggest Flutter conference in Japan, Flutter Kaigi. And I'm also a member of Flutter dev community called Flutter Daigaku, which is run by Kei, the organizer for this conference. Yes. So Kyo and I have been working together on a product called BankUp, and which is a multi-tenant banking app solution for regional banks in Japan, and which, of course, is created by Flutter. And we've recently implemented passkey flow into our money transfer feature for higher security. That experience have led us to choose passkey as one of the main topic for this session. Yes, so let's start talking about passkeys. What are passkeys? So for over 5 decades, password has been the basis of our digital identity. And despite the advancements like two-factor authentication and like biometrics, we rely on password till this day. But because they are around for so long, it doesn't mean the solution is complete. So password have issues on user experience and also security. So as for user experience, long and complicated passwords are really hard to remember for the users. And also typing the long password is for every time is tiresome. And so which often ends up users to use same and simple password everywhere. And even the user uses a strong password, they could be stolen by attacks like phishing attacks, or even stolen directly from database. And also they could be breached with brute force attacks. Then there's passkey, a magical solution that would free us from the issues that we had for the passwords. With a single touch of biometrics, it will allow us to authenticate with higher security. And with the help of API called Web Authentication API, which is specially built for passkey, it allows us to authenticate by using biometrics, pins, or patterns only, and allows us to authenticate with higher security. So we don't have to remember the password anymore. And also, it will achieve the higher security level compared even to two-factor authentication. And by calling Web Authentication API, the device would issue cryptographic a key pair of private and public key. And private key will be stored into a password managers like what was it? The Google Password Manager or like iCloud keychains in a cloud. And the public key will be stored into your database. And when authenticating, these key pairs will be compared, and if they match, we have the authentication. So not only with the public key cryptography, the passkey authentication includes a number of steps to verify various metadata, so which allows us for higher security. And because of its benefits, major tech companies like these are implementing passkeys into their services. And commonly, there are two use cases for passkeys, which is one, for logging in. So by implementing passkey into login, a user can log in much faster and easier. That's an improvement on user experience. And also for securing transactions such as payments and money transfers for higher security. For our product, we've used it for the second use case. Yes.
Now let's walk through the passkey flow. Here's a registration abstract. Here's abstract registration flow. From a Flutter point of view, we get a credential option in step 1 from the server that needs to create a passkey. In step 2, we pass those options to the authenticator, which generates a private key and public key. In step 3, we send the public key back to the server so it can be validated and saved in the database. Now let's go over the registration flow in more detail. Like I explained earlier, in step 1 we get a credential option from the server. On the right you can see the JSON response we receive. You don't worry about the detail for now. We'll keep it high level in this session. In step 2, we pass those options to the authenticator. In the credential option, field marked with red square is your domain name. Apple or Google checks that your app is linked with an association file or asset link file hosted on the domain. After verify, this OS dialog will be shown. Username in the credential option shows up in this OS dialog. Using the credential option, authenticator generates a private key and stores in the cloud. After that, we get the attestation signature from the authenticator, which contains a private key in it. Then we send that back to the server. It's validated and saved in the database. We won't go into detail in this session, but please note that this step is also crucial. After it's done, registration is complete. At this stage, user has successfully created a passkey and ready to be used for next login. Now the registration is complete. Let's take out the abstract login flow. As you can see, it follows a flow that's very similar to the registration flow. Like before, we get the credential option from a server. The credential option is slightly different from the one used during the registration flow. Remember what the credential looked like for registration? Maybe not. Let's compare them in the next slide. On the left, you can see the credential option for registration. On the right, the one for login. Registration one has user metadata and parameters for generating keys. Login credential is much more simpler. Let's go back to the flow. We pass the credential option to the authenticator. Authenticator verifies your app. As you can see, we have the same flow as the registration one. Once verified, this OS dialog vision simulating. Using the credential option, authenticator generates assertion signature by signing the private key. Let's compare the assertion signature with the attestation signature. Attestation signature about credential registration, it contains the attestation object, which includes a private key and credential metadata. On the other hand, assertion signature is for authentication. It includes a signature generated by using a private key. Let's go back to the flow. We get the assertion signature from the authenticator. Then we send the assertion signature back to the server. On the server side, server looked up the public key to validate the assertion signature. With that, login is complete. I bet you have now solid understanding of both registration and login flow now.
Okay, thank you, Kyo. So I think now you have a basic understanding of Passkey flow. So let's try to implement it to Flutter apps because this is a Flutter conference. Yes, let's try to create a sample app that we can register, and also logging. Sorry, this is a bit slow. But yeah, logging with passkey. So simple app. Yes. So to implement it, we need to have one backend server that would issue the credential options and also verify signatures, and database to store challenges and credentials, and also a hosting server to host association files. So we can build this from scratch, but that's too much work when we're working alone. So how about we use Firebase functions for backend server, backend logic, and Cloud Firestore for database, and Firebase hosting as a hosting server. Wow, we can implement all with Flutter. Flutter and Firebase. Yes. So great, that's great. Yeah, so this will be the system architecture for the sample app. So we'll be maintaining the user with Firebase authentication, and we will be placing the backend logic on the Firebase function, and using Cloud Firestore as a database, and hosting association files on Firebase hosting. And not to mention, we will have the password managers like iCloud Keychains, Google Password Manager to store our secret key. And for packaging libraries, unfortunately, Firebase Functions doesn't support Dart, so we'll be using Node.js to implement the backend logic. And for its usage, we have a library called SimpleWebAuthn library, which makes us simply implement passkey into Node.js. So let's use that. But how about for Flutter side? iOS and Android are already equipped with native APIs for using passkeys, such as these. And we can use them by calling through method channels. But this is a sample app, so let's take it easy. So there's a package, Flutter package called passkeys, which is created by a company called Corvado, if I'm pronouncing correctly. And this company is specialized in providing Passkey authentication to large-scale enterprise application. So I think we can rely on that. And both packages and libraries are equipped with useful and easy-to-use class methods to support Passkey implementation for both Flutter and Node.js. So, but before we dive into implementation again, let's try to look into the settings needed for passkeys. So as we mentioned before, we need to host association files on the hosting server. And we will prepare a file called, sorry, the text is a bit small, but we will prepare a file called Apple App Site Association file for iOS, and also assetlinks.json for Android. And these files would include information such as team ID, bundle ID, or package name and fingerprint, which allows us to identify the right application is trying to use passkey for that system. So this is very essential. And also, for iOS, we need to register the domain of the hosting server as the associated domains. Yes. Okay, now we're ready to implement. So, as Kyo mentioned, we'll be implementing both registration and authentication flow. So let's go through the registration flow first. So this will be the abstract flow for registration. We will be calling two APIs. One, begin passkey registration, and finish passkey registration API. And in between of calling APIs, we will be calling a register method on the client side to issue key pairs. So let's start with calling the begin passkey registration. So we'll be passing a user ID as a request parameter to the API. And then the server will create a credential options for the client side. And for this, we have a simple method called generate registration options by the simple WebAuthn library. So we can use that. And for when creating the credential options, we'll be issuing a challenge. And this is technically an ID for this particular transaction. And because we will be using this in later steps, we need to store it somewhere. And usually, we store that on server-side sessions and use it temporary. But as Firebase function is stateless, we will be storing that challenge into the Firestore. Yes. After storing the challenge, we will be sending back the credential options back to client. And next, we will be issuing the key pairs on the client side. And before issuing the key pairs, application will be verified with the association files hosted on the hosting server, and verify if the application that is trying to use the passkey is the expected application or not. And after verifying, we will have this dialog for biometric dialogues. And after that is success, the client side would create the key pairs. And for this, we will be using a register method from passkeys package. And behind the scenes, the secret key will be stored, uploaded into the cloud, like the password managers in the cloud. And at the same time, with creating key pairs, the register method will return attestation signature, which includes the public key issue. And this will be sent back to the backend server through the finished passkey registration API. And in attestation signature, the challenge that we've issued before is embedded. So we will be comparing that challenge with the challenge stored in the database and verified. And for this verification, we will be using verify registration response method from the simple web authn library. So very simple. Then, if it's verified, then we will store the public key into the database. Yes. Then we will return the success to the client side. Next, we'll be going through the authentication. And just like the registration flow, we'll be calling two APIs. And between the calling APIs, we'll be having call authentication, authenticate method to create signature from the secret key in the client side. So it's technically, the flow is really similar to registration. So let's start with calling the begin passkey authentication API. And because the user is before logging in, we don't know the user ID. So we will be passing no parameters on the request for the API. Then, just like the registration flow, we will be creating the credential options again. And this will be done with the generate authentication options in the simple web authn library. Just simple as that. And then again, we will be having a challenge and storing it into the database. And sending it back to credential options to client side. Then again, sorry saying then again so many times, but then again we will be verifying the application with the association files. And on the authentication flow, we'll be retrieving all of the credentials stored in the cloud, and let the users to select which credential to use for that passkey login. This is a part where a bit different from the registration flow. Then, using the credential that user have selected and also the credential options that we have received from the server side, we'll be creating the signature. And when signature is created, we will be having, actually, yeah. So that creating the signature will be done by the authenticate method in the passkeys package. And the signature, authenticate method will return the assertion signature, which includes the signature that we have just created. And we'll be sending that back into the server side through finish passkey authentication API. Then, just like the registration flow, we will be verifying the signature and public key, and also the challenge will be embedded to the assertion signature again, so we will be verifying that too. Then that would be done with the verify authentication response method. Then we will be issuing a custom token and throwing that back to the client side, and we will be having the login. So yeah, sorry for keeping saying this just same as registration or the same as the authentication. I just wanted to emphasize that the flow itself, you might be overwhelmed with the numbers of the parameters and the verification steps, but it's in abstract. I wanted to emphasize that the registration flow and authentication flow is quite the same and also very simple. So it's, if you abstract them, it just go down to just creating the credential options to the client side and doing something on the client side, and just returning the signatures back to the server. So as passkey might seem very complicated and difficult, it is actually a very simple flow. So I just wanted to emphasize that one. So I think you can do it now.
Thank you, Shohei. Now let's talk about our backup system architecture. We use Passkey as an extra layer of authentication before a user can send money. First section shows account creation and account login. Third section is the Passkey flow. Compared with a standard Passkey flow, what's different in our setup is step 1 of the registration. We compare the user identity check with Passkey authentication through SMS or IPR depending on the tenant. Let me explain this step using the registration diagram. Here user select phone number to issue the OTP. Then next user enters the OTP they receive. Then tap on the verified button. App sends the OTP back to the server to verify it. Once verified, we get the credential option from the server. From here on, it's the same flow as the restoration flow I explained earlier. Now I'd like to share some tips for you to integrate Passkey into your project. During the login flow, we get the credential option in this format. As you can see, arrow credential is empty. If it is, it shows all available passkeys even across different accounts. To avoid that, you can include the credential ID in the arrow credential arrays. But where can we get the credential ID? So it is included in the attestation signature during the registration. We store it during the registration and use it for login. For the second tip, I want to talk about the origin check. On the client, it's verified using an association file or asset link file. There's an origin check on the server side. The origin included in the attestation client data JSON. When you decrypt it, you find the origin inside. For iOS, it is RP server's domain name. For Android, it is APK hash. We compare received APK hash with expected one stored on the server. Probably most backend members are not familiar with APK hash and don't know this. So this is something you need to keep in mind. But how to check the APK hash? For development, staging, and some production apps signed by key store, you can run this command to check the APK hash. But most of the apps are signed on Google. I mean, most of production apps are signed by Google. If that's the case for you, you need to go find the certificate from Google's Play Console. Be sure to get the certificate from the app sign key certificate section, not the upload key certificate section. Then using the certificate, run this command to check the APK. Then don't forget to add the APK to this expect origin in the Node.js. Before we wrap up, here one final tip. Sadly, we have seen a few restoration and login attempts failed on the Google and Apple side. This rarely happens and seems to be temporary issues. So we would recommend displaying error, something like something went wrong, please try again later for unknown error and expected one. I would recommend this tip through my past experience.
Okay, thank you. Thank you for listening. So we'll just wrap up. And so as a wrap up, I would like to emphasize on 3 points. So one is that Passkey is technology that allows us to authenticate with not only with the public key cryptography, but with the numbers of verification steps. And seems complicated, but as you have kind of understood, the flows are very simple, and there are details that you might want to be careful about, but just the process itself is very simple, and just throwing the metadata back and forth between client and server. And lastly, you can implement it by yourself with using Firebase, and also the packages that I have introduced. They would handle the complicated parts. So I think so it might be simpler than you might think. So if you're interested, please try it out and experience the latest trend in the digital authentication. Yes, and lastly, I'm sorry about for this advertisement, but lastly, our company, Money Forward, has an open position for iOS and Android dev with Flutter experience. And 1/3 of our developers are non-JP, and most of the communications are in English. So if you're interested in working in a global environment in fintech field, come talk to me and let's connect. Thank you.
Thank you, Shohei and Kyo. So we have time for Q&A. So if you have any question, raise your hand. Our staff will bring a mic to you.
Thank you. Great presentation. My question is, what's the difference between passkeys and simple biometric authentication? Is there a difference in the first place, and why Money Forward went with passkeys? There's a lot of banking apps just use a biometric authentication.
Yes, thank you. Thank you for the question. Yes, I think that's one of the most asked frequently asked questions. And actually, as you have said, there are applications that allow biometrics and just logging in by that without using passkeys. And what is going on behind that scene is actually it's just storing the password in the secure storage in the device and using that password. So it's actually not, it's still using a password. So in terms of security-wise, because it's using a password, it's the security level is lower than the passkeys. And that's the difference. Yes.
Great explanation. I didn't know that actually. Thank you.
Thanks for asking. We were prepared for that.
Any more questions?
At one point, you showed like a one-time password coming from the text. Why would you need that if you have the passkey?
I think this is the part, right?
Yes.
Yeah, it's a requirement from a bank, and we need to check the user identity check, not like using a biometric authentication. I mean, passkey is not verifying the user itself. And that's why we need to check, combine the SMS and IPR with the passkey authentication.
So in terms, as our usage, we have the user and we know the telephone number. So first we identify that device is the correct used by the correct user first. Then we would authenticate that the transaction is made by the actual person who owns the device. So that's like two-step kind of like verification for securing the transaction.
Yeah, that makes sense. Makes sense. It's like two different things.
Well, it's actually like checking a different thing, actually.
Yeah, right.
So by using like both, it's actually there's a protocol. I'm not sure like the word is correct, but like there's a protocol called like FIDO. There's like a protocol created by alliance called FIDO, and which the passkey is included in that protocol. It's not, that protocol is not the passkey. It's just part of it. So passkey is one of the the techniques to secure the authentication, and with the protocol, they emphasize, or like the, what do you call it? Like, emphasize on using both steps to, strengthen the security. If that makes sense.
Yeah, that makes sense. Yeah, thank you.
Thank you.
Any other?
Thank you for the presentation. Can we club Passkey with the Auth0 also, other packages?
I'm not quite sure, but I think you can, maybe.
Okay.
Yeah.
Thank you.
Yeah. But I think, you have to pay for them, right?
It's more common, like using Auth0. It's very common, like most of the apps are using Auth0 for the communication with the backend. So it will be easy to replace.
Yeah, sure. But they're like paid service, right? To use Auth0. Yeah. So well, yeah. If you're like enterprise, like working in a company and like implementing into an enterprise, maybe that's one option as well, of course. And also, like as I heard somewhere, I think Firebase Authentication is trying to implement the passkey feature for their authentication method. So it's not released yet, but I think they're coming up. So I think for that authentication, I think what happens in the back end side is the same flow as same system architecture as we've introduced today. So I think when you're using it, I think you'll be having a good understanding. I hope. Yes.
Any other by the window?
Thank you for your great presentation. I have one simple question. Your product supported both Android and iOS, and when you tried to support both operating system, did you face any differences on Android or iOS? Are there any behavior differences for Android and iOS? This is my question.
Well, in terms of implementation, if you implement passkey in the native side, there's a big difference. But if you are using a package, there's you will not see any differences. But from the user point of view, there's big differences. Like you need to enable the iCloud keychain, and like so when it comes to settings, there's a big difference. But in terms of implementation, there's no differences here.
Okay, thank you so much.
Sorry, to add a little bit. Mainly for the implementation, it might not have much difference, but like we've through our development, we've kind of struggled with handling errors. So both platforms implement their own kind of like error handling, and when we have that error, and we kind of struggled to unify how we would handle that error on the Flutter side. So I think that's one, a takeaway that you might want.
Thank you.
Thank you.
Any other question? It's okay. So thanks again to Shohei and Kyo. Let's give them a hand. So we'll now take a break for 15 minutes. So feel free to visit Ask the Speaker corner for more discussion or questions. And next session is going to start at 11:25. Thank you.